Hi. Today we're going to keep talking about matter, measurement, and chemistry. We didn't really talk that much about matter yet. We kind of talked about just what chemistry was, but this is a natural progression of things. So to get us started today, I'm not going to show a video or have you write down any observations. I just want you to pause the video and just take a look at this list. There are a large amount of terms here, and I want you to do the best you can to categorize them. You might come up with a different categorization than I do, and that's okay. So, if you paused to take a look, I was just taking a look at all of them myself. Hopefully you narrowed things down a little bit. I mean, you probably could come up with some categories that are like really like minute, many categories. But if we wanted to get to a few very large categories, I see things like democracy, wisdom, fear. These are like human constructs. We have ideas and concepts. And then to switch colors, we've got we have things like we have heat and electricity and gravity, and these things are going to come, and maybe to a degree even pressure. These are going to come from energy. And then everything else on this sheet would fall under what we would call matter. Just a quick scan to make sure I got it right. Oh, I'm sorry. Movement. Almost made a mistake. Movement is definitely energy. And then everything else on this page would be considered some form of matter. And there is a dog at the bottom I made sure to show. This is my dog Maya. She loves to do a lot of things, but you'll get to know her over the course of the year depending on what we end up talking about. But to move on, if we wanted to talk specifically about matter today, so we're getting rid of all of those ideas and concepts and energies and things like that. We're going to define matter, classic definition of anything that has mass and takes up space. Now that said, yes, I was looking for some larger categories, but now that we've singled out matter from the other categories, I want to break that down a little further. For this course, we're going to divide matter into three major categories: elements, compounds, and mixtures. You may be familiar with them already, which means this will be a very easy discussion, but if not, I'm totally happy to go along on the ride with you. Matter is, by definition, something that it's matter, it's material composed of one type of atom, or I was about to say an element, but I don't really want to circularly define this. But for now, we kind of have to just say one type of atom and just leave it at that. We'll define this better in the next coming units once we want to talk about what these atoms themselves are made up of, so that we can delineate what a type of atom even is. On the macroscopic layer, you're just going to see an element, and it's probably going to be some sort of solidly colored cube, like all one color, or you may have like some sort of a container, and inside the container you would see, no, not going to use yellow. That would be bad. There would maybe be like some sort of greenish liquid, and again, it's like uniformly colored. So there's a uniformity to it. On the atomic level, if we were to zoom in, what you would end up seeing is all one type of particle is present. So if you zoomed in with your super powerful electron microscope, you might see something that looks like that, and that would be a sample of just an element. Or you might see something, if we were to shade in these spheres and leave the open spheres as different atoms, different elements, this would be one element, and this would be another different element. We're just not going to delineate what that means. And we're going to define that this smallest representative particle of an element is of course called an atom. These are what we're calling atoms. Compounds are very similar to elements. The only main difference is that there is more than one type of element present. So actually, in terms of the macroscopic arrangement, you still might have a solidly colored cube. It's really hard to distinguish a solidly colored cube element from a solidly colored cube compound on the macroscopic level, which is partially why chemistry exists. If you had like a liquid, it would be like all the same color liquid. I didn't mean to make that black, but of course the whole thing would be the same color. Again, uniformity. On the atomic level, though, things would look quite different. So again, if we're going to say that this is like element X and this is element Y, then a compound, they're combined. So containing more than one element. I forgot to mention something. In these compounds, the more than one element that's present have to be chemically bonded or combined together. And so we're going to represent that in our particle diagrams. Oh, no, should not have clicked. We're going to represent that in our particle diagrams by having the spheres be in physical contact with each other. So this would be a certain compound of X and Y. And so if your matter is composed of only that type of matter, only that type of compound, only that type of particle, there's the word, doesn't really matter orientation, right? These particles, they move around, they're floppy. That would be one example of a compound of X and Y. However, since we don't really know anything about how elements bond and make compounds, you might have a different compound, right? It's a different ratio. This 2-to-1 ratio, this would also be a compound. They're both compounds, but different compounds. And two things that are worth mentioning. The smallest unit of a compound, it's not called an atom because there's multiple atoms present. It's called a molecule. So a molecule is that's that unit of a compound. So this would be like 1x and 1y is a molecule of this compound. Both of these types of matter, elements and compounds, we're going to refer to them as substances. And substances simply mean one type of matter in the sample. So that is to say that if you were to zoom in, you don't see, there's only one particle repeated over and over again in your sample. If you had a sample of matter in which multiple particles were present, well, that would be called a mixture. So this would be a combination of multiple substances. This means that could be an element and an element, a compound and a compound, or an element and a compound. This combination is without bonding. This means that when you have the macroscopic view, what you might have is your sample, but inside your sample, if it was, say, a liquid, there would be like two different layers of matter, two very visible different layers of matter, for one example. Or if you had some sort of a solid cube, maybe that solid cube had speckles of like green and then like speckles of blue, and you can see that there's this difference. It is hypothetically possible, and we'll talk about this on the next slide, that a mixture could have a uniform appearance on the macroscopic level. So it's either uniform or not in terms of its macroscopic appearance. On the atomic level, there are several examples. In looking at this, so we have two elements. You might see a sample of matter in which there are multiple non-touching shaded in and unshaded in particles. If it was a compound and a compound, you could see these substances present, but there's two different kinds of substances present. Or an element and a compound, obviously, you can imagine what that might look like. There is no such thing as the smallest particle of a mixture because a mixture by definition has more than one particle in it. You can't really like zoom in. You can maybe zoom in and say two types of particles are present, but to look at these atomic samples of the mixture, there's no such thing as uniform, like there's no smallest unit that's repeated over and over again because if they're not chemically bonded, there's no rule as to how much, right? So this one box here, we would call this a mixture. There could be a similar box that has a slightly different composition, and this is still a mixture. So when I say variable composition, all I'm saying is there's no fixed ratio of substances present. This is in stark contrast to a compound. For the compound, there is definitely a fixed composition. This compound has to be 1 to 1. And this compound has to be 2 to 1. If it wasn't a 2 to 1 ratio, it would not be that compound. And there can be, of course, different compounds. And then I think to wrap things up, that there are two kinds of mixtures, as I mentioned on the previous slide. On the macroscopic level, some mixtures you can actually see the different parts present, and then there are some mixtures that you can't. And so this macroscopic difference in the particle, in the appearance, is going to give us our terms heterogeneous and homogeneous. Different substances either visible or not. So the two examples here, I've zoomed in a little bit on sand. You can still on the macroscopic level see the particles, the different particles in sand, and then of course in garbage, there's a lot of different things in what we call garbage. Garbage is a mixture of, well, yeah, a lot. For a homogeneous mixture, different substances are not actually visible. So what we have on the left here is actually salt water. To look at it, you couldn't really tell if that was salt water, sugar water, or just pure substance water. On the right, we have some candy. These red pieces are they all look solid red. And that's a mixture of course, food coloring and sugar and a little bit of water or corn syrup. So this is uniform distribution. Another word for homogeneous mixture is solution. And we're going to use that word extensively this year. They just literally mean the same thing. So anytime you use one, you can infer the other. So if I say solution, you know that I'm actually talking about a mixture. So you can't use the word solution unless you are. The one last thing I do want to mention about this is the nice thing about chemistry is that it seems like this is an arbitrary distinction, but it's kind of not. It's really based on us. Okay, I guess that means it is arbitrary. When you take, if you took a strong enough microscope and you zoomed in on a homogeneous mixture, it would still look heterogeneous once you zoomed in. The big difference in the fact that we refer to them separately has to do with the powers of our observation and nothing about the actual substances themselves. All the things that are true of a heterogeneous mixture in terms of the properties are the same for a homogeneous mixture, to the best of my knowledge. Yeah. Because it really is they're just a bunch of particles that are near each other. If I zoomed in on these, maybe you'd see something where like you'd have a bunch of one type of particle and then you'd have a bunch of another type of particle. And so you'd see those layers. And then for a solution, you might see one where it's a little bit more well distributed and therefore a little bit harder to see. But they're still both mixtures because we just define it on how they're mixed. So to sum things up, matter can be broken down into three different categories. We've got our elements, compounds, and mixtures. There are two types of mixtures. The names are there. They differ in their macroscopic appearance. And you can actually, through certain chemical and physical methods, get from mixture to substance to compound to element. But we're not going to talk about that today. We're going to save that for a couple days from now. Thanks for watching.